We're moving on to section 20 in the tutorial, and this one is about data annotations. And this is kind of an important concept here too. Um, we've been working with some data models earlier on in this tutorial, and we experimented a little bit with how databases are created and how the data interacts. And basically, what we're doing here is working with a technology that really is, I'm not going to say universal to the whole .NET format, but it is basically utilizable by a large portion of .NET applications, which allows us to basically kind of work in combination with both this code first approach that we have in place and getting data so that it actually works within our applications through validation. And then how do you do validation? And when you get into the conversation of validation, we kind of always like to kind of remember where we came from with this stuff, because a lot of the stuff that we did with validation in the old days, we would have to like manually write like JavaScript code, and then often we'd write server-side code to validate. And then a lot of these things are starting to change now, because really the whole point, and I always kind of like harp on this with students, is the reason we do validation in forms is to make sure that the data enters our databases correctly and doesn't cause problems. What I think is kind of interesting is that HTML5 itself has taken a lot of burden off of like back-end programming, but we did see that some of the validation tools built into MVC are kind of neat the way that they're so easy to employ. Moving on to this topic though here, we are going to be using a number of different tools here, and you can see some of the libraries that are being pulled in. And what they're trying to indicate here are some of the attributes that are basically affecting some of the data that we're working with. And when they say we're working with columns, really what they're referring to is the structure of our database tables and a particular data fields. So we can control certain aspects of what goes in on the front end or even on the back end code, once again sanitizing the data and basically making sure that it fits in there in just the right kind of way. So they point out some of the attributes that go with that, and those couple of listings there. All right, the entity framework that we use in this, within this MVC framework, relies on, as he indicates here, every entity having a key value so that it can keep track of all the different things that we're working with. And what happens really is that the code first approach depends on what is being built. So what we're going to do here is look at kind of a hypothetical structure. So it says the convention is to look for a property named ID by default, because it makes sense if you're tracking entities that everything gets an ID field. And if you guys study database design, that's really kind of a convention. And a lot of modern databases will actually just create ID fields automatically without even asking you, right? They just do it, you know. Why? Because it's good practice. Even if you're not like using it to keep track of your records, it is really just kind of helping to maintain the database in a kind of a solid state. Often, because it's automatically doing that, we can use that that ID as a primary key for our tables very often. But they're going to pull up now basically what is a student database of sorts. And what they're saying is, let's suppose a student class used the name student ID instead of ID, which would maybe be the auto-generated one. So if the code first approach ends up not finding that, it'll basically throw an error saying that it's a requirement that we do have a key property or basically an ID field to keep track of things. So what the annotations basically do is they allow us to basically give a way to designate what the ID is in the absence of an automatically generated one. So you kind of see the mindset there? So when you look at this little bit of code here, they're setting up basically a class file that is, like the blueprint file for creating the data model, indicating right above the first data field that this is going to be the key, right? We're not using a field called ID. We're calling it, some like variation of student ID. But by putting that in there, it will allow us to create a primary key using this approach. Now I'm noticing here it says when you run the application and look into the database, now do you guys feel like you're missing something here? Because I sure do, right? So let me just take a moment here and see if they actually has like samples that we can pull from. So I'm just going to take a moment to figure that out. All right, so here's a little problem I'm seeing is like we're kind of looking at this and we're kind of assuming that we have this code to work with, and clearly we don't. And I just double checked to make sure there's no resources that we're missing, and I don't see any. And I had the students here in the classroom kind of do the same thing. Now, let's just take it on faith that this is what it is, and if we actually end up having to build something, we can go back to some of the earlier examples where we did actually have codefirst data models and then play with this. But what they're trying to indicate here is when you use this approach and you add the key field, and we didn't do that in our previous applications, and then you actually run the application and then go into the database exploration tool, like what they're showing here, you will then see the key appear, and for those of you that have worked with SQL Server in the past, that's a familiar thing. It shows that that field is the primary key for the table. All right, and you can basically add it just by simply adding this data annotation in front of any particular field. So the question I was having here is if we happen to move this and let's say put it in front of last name, yes, the key would then appear in front of last name. And that's a good thing to know. The next thing that they're going to do here is indicate that you can not only have one key, but sometimes primary keys are actually combinations of columns. And if you've done database work, you'll know what I'm talking about. So for example, if you think about, let's say, creating a driver's license database. Now, one of the problems here is a license number in one country, or maybe if you think of like even driver's license, or let's say a license plate, and I'm not really sure what they're referring to here, but it says driving license. All right, so driver's license. You might actually have a driver's license that might be replicated in a different state or a different country. And what they're indicating here, in order to make that license number truly unique, you have to also add a second column, which is not just the license number, but the country to go with it. So both of those will get the annotation of key. So we're really making two columns of key, and then putting them in a specific order so that they can be referenced in that order. Now, the interesting thing is that what they're saying is really look at the license number first and then the country. You could actually change the order of those numbers so that when you're doing a lookup, it would look country first and then key, even without changing the structure of the table. I don't know really why you would do that, but that is a possibility. And a little bit of database design I did professionally, in days past, that was one technique I always used rather than like adding like a generic ID column to make something different, is I would find some other logical piece of data within a database in combination that would make something unique. Another good example of that is let's say we were looking at an example of working with email addresses, right? When you look at an email address, the first part of the email address is the username on the server, and everything after the @ sign is the name of the server, right? So it would be hypothetically possible that, let's say, you had a Yahoo email account and then a Gmail email account, And you could have the same username on both systems, right? So you could see then the username is not actually unique, so it needs a second piece of information to actually make it unique. And maybe that's not the best example, but that's all I'm thinking of right now. So, all right, so it does tell you here that when you do have, composite keys, they're calling them, or combo primary keys, that it does require you to specify an order for them so that the database knows how to index it and make those things unique. Right, and that's what that is showing there. Next, moving on to this timestamp concept here. And notice it says codefirst will treat timestamp properties the same as concurrency check properties, but also will ensure that the database field generated by codefirst is non-nullable. So if you scroll down and start looking at the code, now what would you suppose a timestamp does? Well, I think that's pretty obvious. We're generating a piece of information that's coming from the system's clock, so the date and time, and stamping it in there. And if you guys don't know this, that is a common technique in database record creation. So often you will maybe generate an automatic ID. You might sign a manual ID, like you see there's a course ID here, and put in a bunch of fields. But then often the database admins find it very useful to know when was this record created, timestamp it. When was this last edited, timestamp it. And you put that into the database, and that really helps you to run a lot of queries. Like if you're trying to figure out when a piece of data was entered or changed, that's a field you can go to. All right. So they're actually creating, notice, not just a timestamp field, but really an array of timestamp fields so that you can actually keep track of them to see what's going on. Now to move on to the concurrency check, and notice the way they describe this. He says the concurrency check allows you to flag one or more properties to be used for concurrency checking in the database. So if somebody edits or changes something inside the database, you're going to get a check to see what's happened. All right, so in this example, what they're really doing is they're adding right above title the concurrency check, and then notice right below here, they're then indicating with this like altered version, they're saying timestamp, and the data type is timestamp. So it helps to kind of like narrow it down in a sense and make it a little bit more specific. That's the way at least I like to think about it. All right, now they're showing us a little snippet of code here. And notice what they're saying about it. It says in the above, they apply it to the existing property, and what that will do is it will check the title column first, and then to see if there is something that happened at the same time. So you got to think of what the word concurrency means. So that basically, if you have people like trying to change the same record, which one is going to stick? Usually when a record is being edited in a database, once one user is accessing it, somebody else cannot. But notice how they're kind of putting this together and referring to some of the fields above where it's kind of SQL-like in its statement. So we see very similar syntax, and we're seeing all the data fields being called in a SQL style format. But then notice all the @ signs in there, which of course are basically razor directives and help us to identify those things basically as variables that match up to the column numbers and the concurrency checks, which helps to kind of narrow it down once again. Another annotation that we can add is required. Now, I think that's kind of a no-brainer and should be pretty quick for you guys to get. But if you are putting together a table, often might be information that must be there, right? So you can even think really basically to HTML forms in that capacity. And a lot of times people will design databases and not enforce that requirement. And then of course, that's very problematic in an application, because if you don't have consistent data, the data really loses its value. So if your goal here is to create a student class where you're holding student information, oh my God, absolutely you need to have their information in the table. Otherwise, how do you know who it belongs to, right? So if you don't have first and last name along with an ID number, what are we really doing? It doesn't make sense. The directive is very simple. It just says required. And then, of course, if you have that in your data structure and you're trying to leverage it and you're not putting the data in, it will trigger things within the application. So it's really basically a way to enforce the database design is the way I like to think of that. Does it really matter if a person has first, middle name? Well, apparently, yeah, it does, right? Because a lot of people can have the same last name. The fact that they have a different first and middle name might more likely be unique. Does the enrollment date have to be there? Of course not, because maybe a person is a student but never enrolled, or something to that effect. I mean, you guys know kind of the game there. Now they show us a little bit of a result here, and if you check the screen real carefully, and boy, my PDF is kind of bouncing up and down there. I'm not sure why. Maybe my mouse position was weird. And notice it says it'll add a not null basically to some of these keys or some of these things here. So you will not have the ability to put in a null, and that's so these boxes here on the side are not checked because you cannot have these fields be null. Notice also in the SQL output at the bottom, which I think is equally as telling, is it equates to, so the required annotation equates to putting not null into a SQL statement when you're defining a table. Another real common database thing to do is to check for the length of the field. So you might design your database so that you have a maximum capacity for certain things. In this case, it looks like they're trying to title a course, and they're trying to limit the description of the course to 24 characters. I know here at Gateway that we have some courses that when you print them out in certain formats, you don't get the whole name shown. I can't think of any of them off the top of my head, but I know there's a few, at least in some of the databases that I look at. So you can actually determine a max length for a field and basically control the creation of the database that way. Notice that in the output approach of that, when you look at the database, the title does have the varchar thing in there, and it is listed at a max of 24 character. This one does have a check marked by allow nulls, so of course that says nulls are allowed there. Minimum length works very much the same way. And notice here what they're doing is they're putting it in combination with max length. So they're saying you got to be at least 5 characters, but at most 24. Yeah, I can't think of too many courses you could probably give a course title to with 5 characters. Okay. Maybe if you just call a class like PHP or something, perhaps. But that's usually not going to be the case. So you can set that up. Another thing you can do is you can work with this property, which is string length. And very similar to max length, but this does apply to strings. And that is a little bit different because if you think about max length, that could be applied to a number, right? Most often it would probably be applied to text, but this actually enforces that whatever field you're doing it with has to be a string data type. in the database. Moving on to tables, they indicate right here at the top of this section, it says the default when you do code first is that the table name that is created is the same as the class name that's creating it. However, you can override that feature, and you see that basically what they do is they put an annotation right above the class declaration to give it a different designation so that the outputting or outputted table from running code first would then appear in the database as student info, even though the class file that created it is actually student. That's a pretty simple one to see. So if you looked at the output here, you can see in the schema that it is student info and not student, even though it was created by a class file named student. The other thing that you can do using that particular annotation is you can also add not only a unique designation for the table, but you can also add it to a schema. And remember, all a schema is basically it's a namespace or a hierarchy for making sure that something is unique. Just in case, maybe you have a student info table in a section other than admin. So you might have one for admin and you might have one for who knows what, sports or something. I don't know if they have an example of that here. They sure do. And then what happens is instead of having the generic DBO, database object schema that it's part of, it actually fits into the admin schema and really further makes it unique once again. And that, I don't know if you guys are catching that as a theme, but that, a lot of times when you're working with databases, it's not unusual to end up with the same table names. So the only way that you can kind of differentiate them is to break them up with schemas. Same is true with why we have namespaces in C# files. It's not unusual to be creating files that have like index methods and then certain classes, and then the only way to differentiate them is to then nest them inside of something that's named, and then you have the uniqueness that you're looking for. Right. Another annotation is one called column, and let's read what they're saying here. It says kind of the same as the table attribute, but it overrides the table behavior, while the column overrides the column behavior. So if you think about what a table is, that's the entire structure. The column is just one data field within that. So let's take a look at an example of that. So here we actually, in the class file, are calling the string first and middle name, right? But in the column designation, we're just calling it first name. I don't know why, because it's shorter maybe or cleaner. I really don't see I wouldn't go to that trouble personally, but they're just, setting up an example, right? So I think you guys are latching on to that concept now. All right. Moving on to the index annotation, and they make a little important note here at the top that this actually was added when Entity Framework 6.1 came out. There's a chance that if you're working with an older version of Visual Studio, and at this point, I don't know how old that particular framework is, but you might have to go back to like Visual Studio 2012 or earlier, is my suspicion, for that to be the case. Then what they're telling you is like, don't even bother looking at this section because it's not going to help you out because it's new. All right. Now what this helps us do is this helps us to create an index for the columns that are in the table. Now, for those of you that aren't familiar with what indexing is for a database, indexing is a way of kind of organizing the data in a database in advance. Okay, so let me give you an example. If you walked into a library in the old days, before they had computers for the card catalog, you would walk up and they would have 3 sets of index cards, right? And one set would be subject, the other would be title, and the other would be author. Now the data in all the cards is all the same. The only thing that was different is what order they put it in. So in that example, they had one column for subject, right? So they would arrange all the subjects alphabetically, so you could find, like, if you were looking up computer programming, you'd look under C. And then if you were looking for the author, then it would be indexed by author. So it's just an ordering mechanism. And so what this does is it creates the index for any column. A well-designed database table that has a lot of data in it often will have multiple columns that are indexed. And then if you're trying to search for something, you can say, well, sort alphabetically or sort numerically or whatever the case may be, and then you're basically arranging the data. Why that's important in a database is because when the data is indexed, you can call upon a certain index to help you find information faster. That's really the key there. So by just putting in that annotation, then we can run information and pull it back. If you do look at the table here, the output, like in the database view, you'll notice that this title field does have an index created, and down here it indicates where the index is, and then of course, there's different formats for creating indices. So in other words, you can sort it, A to Z or Z to A, that type of thing. The default, of course, is to sort ascending. There's another thing that you can add into the mix with an index, and that is this additional parameter, which is unique, meaning that, okay, and going back to the library example, so this is a good example. A book at a library, whatever book number they put on it so you can find it on the shelf, the Dewey Decimal System or whatever they called it, those all have to be completely unique, right? Or like an ISBN number on a book. However, you could go to the author's card catalog, and you could have 20 authors with the same last name, maybe even the same first name and middle initial for that matter, right? So what this would enforce is it indexes it if it is unique, so just, to explain that. So I think that's pretty common. Another one that's real common in database usage, and I feel like this chapter is more about teaching you about databases now than anything else. Right, but they're showing you that we have these tools available when we're building a code-first approach, and the foreign key is one of those things that you build into databases too. Now we know what a primary key is, right? And that's where we set up a unique identifier so that everything in a table has its own unique identifier, so we don't have duplicates. But sometimes when we're trying to add a key to a secondary table, we have to enforce the fact that the key exists as a primary key somewhere else first, right? So in this enrollment table, I need to enroll the student, but I can't enroll two students with the same ID, right? So what you would do is you're going to try to enforce the fact that you have a unique key in a different table. And since it's a different table, it's foreign to that one, so thus foreign key. And that's a really fast explanation of foreign keys, which isn't really ideal. But what will happen here is you need to put in actually the whole word foreign key and which one you're referring to, so that when you're tying it back to the original table to make sure it's unique, that it has that connection. That's a big part of database design, and you guys should have learned that in the database class, and I'm pretty sure you did. All right, and they show the results here. And then, in as far as SQL statements go, when you look at how they lay out, and I'm zooming in, yes, a little bit so you can see that. When you do SQL statements, those come in as constraints, basically enforcing the fact they have a primary key that attaches to a different table. And they show the syntax here. And my goal isn't to teach you SQL, it's to teach you how this technology works. But you can see why it's important. All right, this next one talks about how when we're doing code first, and it says one of the default conventions, is that everything that we're working on that has that we're building into our class files, that they automatically have a getter and a setter, right? That's kind of like pretty typical when we're creating class files. But you know what? There's circumstances in which you really don't want to have getters and setters. You know, you maybe don't want to be able to change a piece of information, and or in some cases not even be able to retrieve it. So what they do is they add this attribute to kind of prevent some of that from happening. So, for example, they're not mapping in this example father name, and I'm not really sure what the rationale is here, but maybe they're looking at what a maiden name is for somebody, and that's not going to be changeable no matter what. Okay, then I think that's kind of the thing. So they're not mapping it out, and then that attribute gets added in the file as an output. And it says codefirst will not create a column for a property which does not have either getters or setters, so it doesn't even get added to the database. Right, another interesting one here is one we call inverse property. And this one actually looks at when you're trying to tie multiple files together across different tables. So they use the example of an enrollment class, because really what will happen here is a student is a unique database table, right? So students are unique. We also have courses. And although courses repeat over semesters, each semester they actually get a unique section number. So they're really unique instances. And then, of course, they're enrolling in the courses, and then ultimately they get a grade and stuff. And really what's happening is you're kind of tying a lot of pieces of information together from a lot of different sources. So what that inverse property does, it allows you to basically force a way to make sure those things are tying together properly, kind of forming the relationship between the table. So really what it does is it creates this connection between the particular class that you're using as your data model and how it ties to the primary key and then relates to the foreign key to pull all the information in. So really, relationship enforcement is kind of how I'm seeing this. And then if you look at the outputting result, once again, you'll see that there's a whole bunch of connections here to outside tables and foreign keys. And if you look at the resulting SQL code at the bottom, when you are tying to different tables like course ID and student ID, nulls are not allowed. You have to have them there to make those relationships work. All right, they give you some examples of that. The inverse property, of course, comes into play here when you're calling it, and then that enforces those connections via code. All right, and they give you the other example there as well. Folks, that ends section 20. I'm happy to say that I guess that was lecture only and no exercise, so maybe you guys are cheering right now. So this video ends here. We're going to move on to section 21 in just a moment.